Hello. If you haven't subscribed to the channel yet, I would request you to go and please subscribe. As far as this course is concerned, we are doing geography, particularly world geography. We have completed part 1 where we have talked about Earth and its evolution from NCRT. Okay. Now from NCRT, we are continuing with the other topics such as geomorphology. So the topics that we are going to discuss include rocks. After rock, we will talk about earth movements. For example, geomorphic processes, which are exogenic and endogenic in nature. We'll talk about weathering, erosion, as well as deposition in exogenic process, whereas we will talk about slow movement and sudden movement in endogenic process. As far as sudden movements are concerned, we will talk about volcano and earthquake. And in slow motions, which is also called as diastrophism, we'll talk about the horizontal movements as well as vertical movement. The vertical movement includes the upliftment or upward or downward movement, which is basically the continental building forces, whereas the horizontal movements are basically stress and strain inducing factors, which leads to the mountain building. So this include compression and tension, and that is how we are going to discuss each one of them. So we'll start with the first topic, which is rock. So as far as rocks are concerned, there are three types of rock, which first is igneous rock, second is sedimentary rock, third is metamorphic rock. Now, if we talk about feldspar and quartz, so feldspar and quartz, they are basically the most common minerals which are found in all rock. Most common. All right. So now we'll do a rock cycle. Okay, a rock cycle. That how the rock cycle is. So we'll talk about certain. For example, magma. Okay. Now this magma will lead to igneous rocks. Okay. Now this igneous rock under the influence of weathering. Okay, they'll be converted into sedimentary rock. Okay, sedimentary rocks. These sedimentary rocks will basically first there'll be sediments. Okay, this when igneous rocks will be subjected to the weathering, so there will be sediments. Okay, first sediments. Now these sediments will consolidate and will form sedimentary rock. Sedimentary rock. Now these rocks will undergo chemical changes. Undergo chemical changes and will become metamorphic metamorphic rocks. Now, after melting these metamorphic rock under the Earth's surface, it will again lead to magma. See, we haven't talked about the plates, but ocean, continent, and ocean. These are the three plates. Now, when two plates they collide with each other, the denser plate, which is mostly oceanic, which is denser, it will subduct under this plate. Okay, so this is the moment of Earth's crust. So in this crust, there will be definitely metamorphic rocks also. So when these rocks will enter into asthenosphere, which is the uppermost part of mantle, then the magma will come up, and here we'll find a mountain ridge. All right. So this is something that we will discuss afterwards, but I just thought of giving you a basic insight about the topic. Okay, so here we'll focus on rocks cycle. So when magma, it will go under crystallization, it will turn into igneous rocks, and igneous rock after weathering will become sediment. Now this sediments will consolidate and will become sedimentary rocks, and when there will be change in the chemical composition, it will transfer into metamorphic rock. See, there is also a way by which this igneous rock can change into metamorphic rock, that is chemical changes. So basically this is a cycle where there is a connection where things It is not like only a metamorphic rock will go to magma, or even igneous rock can be converted into magma, right? If it is in the batholith. Now, what batholith is something we'll do when we'll do volcanism. Okay, so here the only thing that is important to know is the rock cycle, which we talked. Now we'll talk about the topics such as the various types of rock. The way we have talked earlier, there are three types of rocks. One is igneous rock, metamorphic rock, and sedimentary rock. There are certain properties of each one of them. We will talk about them. Okay, so first start with igneous rock. Okay, igneous rock. So as far as the igneous rocks are concerned, they are primarily primarily formed out of the magma. Okay, and hence they are also called as primary rock, because it gave lead to even metamorphic and sedimentary rock. Second is that there are certain examples such as granite, basalt, pegmatite, and gabbro. Okay, and gabbro. So these are certain examples of igneous rock. Now we'll talk about the igneous rocks characteristics. Crystalline. First characteristics is crystalline. It does not have, it contains no skeletal remains. No skeletal remains, because at the time of formation of magma, we will see that. So when magma it comes onto the surface, it burns literally everything. So there is no skeletal remains or any remains in this particular igneous rock. These deposit through compaction turns into rock. Now this magma, sorry, pardon me. Now these are certain examples. So if there are two types of igneous rock, one is, now this igneous rock is also of two types. Okay, extrusive rock and intrusive rock. Okay, extrusive rock and intrusive rock. Now the extrusive rocks, they are formed by rapid cooling. They are formed by rapid cooling. Okay, and for example, extrusive is basalt, and for basalt, the Deccan trap is the best example for extrusive rapid cooling basalt and igneous rock. Next is intrusive. Intrusive, sometimes it means that instead of this come to the surface, what will happen? They'll cool down. Okay, and when this above sediments will be worn off, that time it will come into the picture, and we will be able to see this intrusive rock. Okay, and what these intrusive rocks are, extrusive rocks are, these are also discussed in the coming part of these videos, so you don't need to worry about them more. Okay, so it's cooled down. First it cools down. Second is that the slow cooling, basically it allows big size crystal to be formed, and hence granite is typical example of intrusive rock. Okay, so this is the two things about it. Next is sedimentary rock. Sedimentary rock. Now sedimentary rocks, as it suggests, it is formed from the compaction of these sediments, and it is a result of denudation. Denudation, it means basically the weathering and erosion. Now these two things, that is weathering and erosion, will lead to the formation of sedimentary sediments. Okay, now the sediments, the little sediments, they are worn out of the igneous rock, will now consolidate and compact, and now that there will be the formation of sedimentary rock. Now, when you see that this is a sedimentary rock made of sediments, so anything which comes under sediments will also eventually be part of sedimentary rocks, and hence here you find the skeletal remains. Okay. Now it is 75% of the Earth's crust, approximately 75% of Earth's crust. But if we talk about volume, it is only 5%. Okay. The next important thing is that, as we talk about, that it is not igneous rock and it is made of sediments through compaction. So you find the skeletal remains of animal bones, right? Then you also find the skeletal remains of plants. Okay. The different varieties of sandstones are also spread over Madhya Pradesh, Bihar, Odisha, Himachal Pradesh, etc. So depending upon the formation, they are basically classified into certain points or parts. That is mechanically formed, second is organically formed, and third is chemically formed. Okay, so there are basically three types of sedimentary rocks which are formed through three processes, which is mechanically formed, organically formed, and chemically formed. As far as mechanical formation is concerned, we write down the example of sandstone, conglomerate, limestone, etc. If we talk about organically formed, the best example is coal and some of the dolomites. If we talk about chemically formed, then the rocks such as salt, iron ore, chert, etc. are basically the sedimentary rocks. Now the last in this list is the metamorphic. Metamorphic, okay. So if we talk about metamorphic, the first point here is that it forms under the action of PVT change. P stand for pressure, V stand for volume, T stand for temperature. So under these three conditions, when rock will come into these three condition, it will be subjected to changes. These changes are chemical or physical in nature and will lead to metamorphic rock. Metamorphism occurs when rocks are forced down to lower level than the tectonics, or crystallization and reorganization of material take place. And in the process of metamorphism, some rocks, grains, and minerals get arranged into layer and they form foliation. So if there is a question that foliation is a characteristics of, if there is a question come that foliation is a characteristics of, so you can take on this material, that is metamorphic rock. So foliation is a characteristics of metamorphism. It is also called as lineation. So what happen, you'll find this banding across it. Okay. So under the PVT change, certain material, for example granite. Granite is a example of igneous rock, that is intrusive. Granite will convert into gneiss. Okay. Clay and shale will be converted into schist. Sandstone will be converted into quartzite. coal will convert into better form, that is anthracite and graphite, and limestone will become marble. So these are the basically the structure. Now the most important part in this discussion is this that I'm writing down. If we talk about the abundance, that which rock is found in highest quantity. So remember the sequence: igneous rock, metamorphic rock, and sedimentary rocks. Okay, IMS. So remember this thing: igneous rock, metamorphic rock, and sedimentary rock. This is the sequence of abundance of these rocks which are found in the. Now the next topic that we are going to start is geomorphology. As previously discussed, we completed the topic rock. Now we'll talk about geomorphology. Okay, so as far as geomorphology is concerned, it is the study of physical feature, physical features of the Earth's surface and its relation to geographical structure Now, what are the geomorphic process? That is what we have to understand. So the formation and deformation of land. So and deformation formation and deformation of landform. Formation and deformation of landforms on surface of Earth are continuous process which is due to the continuous influence of external and internal forces. Okay, so now we'll talk about the certain forces. First, Earth. This is widely accepted, or this is a universal fact that Earth is undergoing deformation. Okay, so deformation and formation is an ongoing and continuous process, and this is a well-established fact that Earth is going ongoing deformation. So, what are basically the you see, there are various processes which are responsible for deformation. Now we'll talk about what are them. So the first is the heat general, that is the primordial heat which is stored in the earth. Second is radioactive materials which are there in the earth. Okay, and the property of radioactivity. Third is the tectogenesis, that is the movement of crustal plate. Okay, the movement of plate, that is crustal plates. Okay, and the fourth is rotation of earth. Now if we talk about certain aspects such as climatic factors. Okay, so there are certain aspects, even climatic factors, including climatic factors such as the action of wind, water, okay, pressure, belts, etc. Okay, so these are nothing but the climatic factors which are responsible for the ongoing deformation of earth. So we will broadly classify them into you say certain forms. So how are we going to classify them? It is like, see, these are the earth movements. So the earth movement are basically widely, they are of two types. exogenic and endogenic. The endogenic movements are also divided into two parts that we will talk. First, we'll finish exogenic. So there are three types of exogenic process. First is weathering, second is erosion, and third is deposition. Now consider a rock here, okay, and there is sun, and even at some moment there will be clouds and there will be rains, okay. So what will happen, you'll see that the alternate drying and getting wet and then sunburn, this topic term will help denude or deform this rock, and there will be foliation, there will be the small particles which will be losing from this parent material, okay, and will this process will be called as weathering. Now we'll talk about weathering, and it's different in the further part here, that is important. Now the wind, okay, now wind will come, even rain will come, and these little particles will start moving, okay. So that is basically will lead to a structure which is like this, okay. So this is something which is eroded, so the erosion. And when this particular part, if suppose for example say there was a depression, okay, and this was a mountain, so this will be coming here with water, okay, with rain, and then this will start filling, and this will be covered. So this is basically the deposition, and then there are further ways we can decode these three processes, and we will do it further in this video. Now we'll talk about the endogenic factors. Now there are two types of endogenic processes. The first is slow and the second is fast, or called it as sudden. Talk about the sudden. First is earthquake and volcano. You see this, you can even talk about tsunami, but tsunami is something which is an outcome of earthquake, okay. Tsunami is an outquake of earthquake. Next, this slow process is called as diastrophism. Now these slow processes are further divided into vertical process and horizontal process. So there's vice chancellor, okay, to a university, and we have a very important word in the Hindu culture, that is Om. Okay, so just remember these two things here. So when we talk about vice chancellor, relate V, that is vertical, with continental, continent building. So if there is a continent which is building, so either it will be upward or downward movement, or downward movement, right? If we talk about horizontal movement, there'll be block mountain and fold mountains, right? So either it will be tension as, or it will be compression, or tension. So, and yes, h is here horizontal. So horizontally, this particular, that is horizontal, is also called as orographic, pardon me, orogenic, and orogenic, O, right? Here O comes from here, and M comes from for mountain building. Here continental building. It is also called as epirogeny. Okay, so this is the basic difference and characteristics uh, that I have tried to explain in a form of diagram. Now the next important thing here is that based on the above diagram we can clearly state that there are two types of movement. One is endogenic and the other is exogenic. Now in deep we have to study each one of them. So we will start with one which is endogenic or endogenetic movement. So as far as endogenetic movement is concerned, the movement is inside the earth crust or interaction of matter and temperature generates these forces. So first it is inside crust, hence endogenic forces. Now earth movement are mainly of two type that we have talked. First is diastrophism, which is slow, and then second is sudden movement that we have talked, right? Earthquake and volcano. Then from where does this particular part, that is endogenic movement, get energy? So this is radioactive energy, radioactivity. It gives it energy. Then there is tidal force, then Earth's rotation, then friction, and the most important is primordial heat. Okay. Now this energy due to geothermal gradient and heat flow from within induces diastrophism, that is slow movement, and volcanism, which is sudden movement in the lithosphere, and hence this particular thing causes PVT, that is pressure, volume, and temperature changes, and hence the rocks will be converted here into metamorphic rock. Okay, because there is PVT changing happening. Now we'll talk about the slow movement. These are the energies which we have talked. Now we'll talk about the diastrophism or slow movement or diastrophism. Now as far as this thing is concerned, that is the slow movement. This diastopic forces refers to the force generated by movement of solid material of Earth's crust. So all process like plate tectonics, orogenesis, epirogenesis, earthquake, etc., that move, elevate, or build up the portion of Earth's crust come under the diastrophism. So anything which builds or destroy Earth's crust comes under the diastopic. So all processes, what will the process which are associated? For example, plate tectonics. Now what plate tectonics is, we'll study later. Okay, orogenic ओरोजेनेसिस ओरोजेनेसिस मतलब क्या होता है माउंटेन बिल्डिंग प्रोसेस कौन से कॉम्प्रेशन टेंशन compression and tension. The next is this particular part, they are basically contributing moving, elevating, subducting, moving, elevating, and subducting Earth's crust. Okay, so these diastopic forces, and particularly they talked about certain phenomena, these help in moving, elevating, and subducting Earth's crust, and hence they are called as the diastopic forces. These slow movements are further divided into two, that is vertical and horizontal. Vertical are basically the continental building forces, and the horizontals are the, pardon me. Okay, so the horizontals are Orogenic, okay, and orogenic are mountain building process, and verticals are epirogenic, which are continental building process. So we'll talk about the epirogenic, or it is also called as continental building, continental building processes. Now, epirogenic movement is basically the vertical movement. It is vertical movement. It means there will be either emergence or submergence of coast or a continent or a plate. Okay, we'll call it simply as plate. So it is a continental building process and which involves upliftment or subsidence of large part of Earth's crust. Now we'll talk about the two things that they have talked. Vertical movement first is upward and the second is subduction. So first we'll talk about upward movement. If we continue with this, that is the upward movement, we realize that due to vertical movement of Earth, some Earth crust emerges there by leading to elevation और upliftment. ठीक है, तो जब वर्टिकल मूवमेंट होगा तो एक तो ऊपर जाएगा या नीचे जाएगी. ठीक है, if this is a plate, so it will either go up or either will go down. Second is that if we see that the beaches, okay, so there are certain beaches which, if suppose, if earlier water used to be at this particular point, after a certain time you will see that this particular portion has little bit of raised structure, and you will realize that now this is the level till what the water reaches. Okay, so this is basically the beaches which are raised. If we talk about the example here, you can write down the Sierra Nevada. Okay, if I won't write down where it is, you just go and find it out on the map that where this particular part is. Second is Black Forest mountain of Germany. Okay, I'll write down it is North America. The next is that with the raised beaches, we also find certain example of sea caves. Okay, certain example of sea caves. We also find certain example of elevated wave cut terraces. Okay, so these are certain which comes under upliftment. Now, if we talk about the subsidence, if we talk about subsidence, uh, due to the vertical movement of Earth, some Earth crust submerges. For example, our Western Ghat. What we call Western Ghat to be, and then we have it, Eastern Ghat. So here we call it as emergent coast, and here it is submergent. So Western coast is submergent and Eastern coast is emergent coast as far as India is concerned. Okay. So yes, you can cite the example of India here, Eastern coast on upward movement. Okay. Next is subsistence. For example, I have given you what subsistence means. Basically, if, for example, if you see Western Ghat, okay, okay. So subsistence. So there are certain examples. First, we can write down the western coast of India, then Mammoth Cave system in Kentucky, and Karst topography. Okay, so these are the examples of subsistence and epirogenic, that is continental building forces. Now, you see that there will also be the presence of peat and lignite below the sea level. Okay, in Sundarban and Tirunelveli. So this is an example of subsistence. For example, if there are something which are available only on the surface, okay, and if after million of year you find that this particular part is something that you have found underground, so you can conclude or you can say safely that apart from after some time or after some years, submersions have taken place. Okay, submersions have taken place, and similar example is given in Sundarbans and Tirunelveli, where the traces or the presence of peat and lignite, have been found underwater. So that is the example of subsidence. Now, if we talk about Andaman and Nicobar, okay, they are basically the part of Arakan coast, right? You must have heard the Rohingyas. Okay, so Rohingyas are the ethnic community of, right, Myanmar. Okay, so on this western coast, you'll find that the presence of Arakan Mountains. These Arakan Mountains are continuous, but you'll find that between Andaman Nicobar and Myanmar, that range has been sunk. So that is then also example of submersions. The next topic here is, okay. So the next topic here is the orogenic and mountain building process. So for it was VC or electric vehicle. Electric vehicle, it means a pyrogenic force vertical. Okay, and vertical forces is also continental building. Okay, continental. So pyrogenic forces means continental. Now here it was home, and the second word was home without E. But we'll just write down small e. So H stand for horizontal movements, O stand for orogenic, and M stand for mountain building process. So just kindly remind this. Okay. Okay. So orogenic movement are basically horizontal, okay, and which basically involves tension or compression. Okay, and then this both thing will lead to the mountain building. For example, fold mountain will be forming, or you will see valley and mountains. Okay, so this is a standard example of tension. Okay, and when there will be so this will become mountain. Okay, and now we'll talk about certain forces which are important for compression as well as tension. So the first is compression. So these compression are the forces which push a rock strata against a hard plane, or basically क्या होगा ना compression में, it will push it to one side which is hard, or from it will push from both the side. So are the forces which push rock strata against a hard plane or one side, or from other side, or both the sides. These compressional forces lead to the bending of rock, and we get an example of fold mountain. For example, take your handkerchief, okay, and then you start putting a pressure. So you will find that, so, in the beginning there will be ripple formations, okay, and then when you'll take them closer, you will realize that it is like this. Okay, so this is when you will put this type of pressure from both the side, this will happen. That is the compression. For example, if we are going to write, this is very famous: Himalaya, Andes, Alps, etc. will come under compression. Now second is tension. Now in tension, the simple thing you have to remember is this. Okay, that is work horizontal and in opposite direction. That's it. And by this way, what will happen if this both thing is happening? So what will happen? The weaker one will fall down, and hence there will be a creation of valley. Okay, if you talk about Vindhya, Satpura, and Rift Valley of Narmada, right? So you will understand that what the tension it means. Okay, so this is not the tension which basically looks like something from physics, that there is a pulley and then this is something how tension looks like. Okay, so that was a lame joke. Fine. Next is earthquake and volcanoes are considered in detail when we'll do it in the chapter earthquake and volcano separately. Now we just have basic understanding that what earthquake means. So just make sure that you have that, and after when we'll do the particular chapter, you will realize that how easy it is becoming. Okay. So now we'll talk about certain theories which are relating to endogenic forces. Okay, so there were certain theories which are related to endogenic forces, and there can be a separate question on each theory. And second thing is that on there can be question on match the pairs, that who gave this theory. So we will write down the theories and then we'll talk about them. Okay, so the first is continental drift theory, which was given by Alfred Wegener. Okay, then second is convectional theory, convectional circle or convectional cell theory, which is given by Arthur Holmes. Wasn't the brother of Sherlock Holmes. Wasn't. Okay. Then Seafloor Spreading. Seafloor Spreading was given by Arises. And the fourth, that is plate tectonic. So plate tectonics was given by Mackenzie and Parker. Okay. So these are certain theories that we are going to discuss, and after that we will move to this next topic, which is the type of plate boundaries and basically how this subduction, diversion, and transformation takes place. Now, as far as the continental drift theory is there, sit down and just listen to the story. That is it here. Okay. So now, first, that the continental drift theory was suggested by Alfred Wegener in the year 1920. Then, according to this thing, Alfred Wegener, there was, if this is Earth, so there is a landmass called as Pangea and a very big ocean, that is Panthalassa. Now, after this there was a division. It created two landforms, upper one that is northern Laurentia and southern Gondwana, and the sea which was there in between was Tethys Sea. Now there was a break of Gondwana and that thing will continue. Okay. So this is a story. Now next thing is that what were the forces. Now you said that continent was broken. Now you're also saying that this continue of that Laurentian moved northward and Gondwana, even Australia went here, India went here. Okay, even this Laurentia broke up into North and South America and Europe basically. So what were the bases that you were saying, or how dare you said that? So next is that what were the forces which were responsible for continental drift. So there were two forces which were responsible as far as the continental drift was concerned. The first force is the equatorward force. Okay, that is the due to the interaction between the gravity, pole fleeing force, and buoyancy. So there can be a question that what were the forces of Alfred, according to Alfred Wegener, responsible for continental drift theory. So the first force was gravity, undoubtedly, or you can say the interaction between gravity, pole fleeing force, and buoyancy or buoyancy. The next is the this was basically the reason for equatorward movement. Okay, this was related to equatorward movement. Okay, now there was also a westward movement. So westward movement was led due to tidal current. Okay, so that is what was stated by Alfred Wegener. Now there are certain evidences in support of Alfred Wegener. For example, if this is Africa and this is South America, so you find that there is a perfect mismatch according to like even Europe, even here America. In America, Northern America particularly, you will find that the Greenland seems to perfectly fit with Ellesmere and Baffin Island. Now you have to find the location of these three things. That is Greenland, which is very common. There's no greenery in Greenland. Okay, then there is Ellesmere, where it is, find it out, and the third is Baffin Island. You have to find it. Okay, so this is second. Then there was this is the first, and we talked about Africa and South America. Second was the Greenland. Third is that the western coast of India, Madagascar, and Africa. They have basically been joined together, and we find the sediments deposit across the con- uh, okay across the borders, or we say uh, that beaches where we find the sediments or similar types of rock. Even the veins of gold of Brazil is found in here. Okay, when there is no apparent material for that still, that is also an example. Then there are various reasons that he cited, and these were the prominent ones. Now there was a various criticism came because these forces were not adequate to move such a humongous continental, plate. So this basically was criticized first. Then, according to various scholars, this coast, okay, the beaches, they are the temporary features, and hence it can't be the reasonable reason for that. Then continental drifting theory shift India's position to much to the south. Uh, this particular thing, that is Africa, Madagascar, Australia, and India. Okay, so this was something a part of Gondwana land, and then it broke down from here. So it makes sure then it says that India does not have any relation with this Mediterranean region. Then second is the mountain do not always exhibit geographical affinity. So that is also some of the reasons that were cited for this thing. Now we talk about the convectional cell theory, which was given by Arthur S. in the year 1930. So as far as his theory is concerned, he says that these currents, that is the convectional currents. Now, what these convectional currents are, they're only understood when you have the knowledge of plates and plate tectonics and how this will basically happen. Okay, so there are convectional currents which are okay going below the plates. Okay, so there are various currents. So we'll do it when we'll do volcano, earthquake, etc. Right? In that particular area, you will understand this concepts better. So the convectional cell theory. So the main forces for that was radioactivity according to Arthur Holmes for convectional theory. Then according to this theory, the intense heat is generated by radioactive substances in the mantle and seek to escape from there. Okay, and that is how the convectional current rises. Now whenever this rising limb of these current meet the oceanic ridge and are formed on seafloor, and whether the falling limbs meet trenches are formed. So whenever you see that this convectional current rises here, this convectional current rises, you'll see that when this rising limb of this current meet at oceanic ridge, meet at oceanic ridge, mid-oceanic ridge. For example, the very famous between both the continents, Africa and South America. There is, okay. So if it is found here, they'll be making trenches. Oh, sorry. If it is found in the center, it will make oceanic ridges. Oceanic ridges. And if it is found here, that is when continent and oceanic plate will go down. So this particular portion will be the trench, and trenches are the deepest portion of the ocean. Now the third is seafloor spreading. Earlier it was believed that if this is the land and this is how the sea start, so this was sea according to the earlier assumption. But then it was realized that sea is dynamic phenomena. There will be beaches, continental rise, continental fall. There will be trenches. Okay, then there will be certain features. Then there may be goyots, sea mountains, then certain plain. Okay, and again the continental rise and etc. So that is what was realized afterward when the study was conducted. So the sea floor spreading was given by Harry Hess. He continued with the convectional theory, and intense heat tries to escape due to the convectional current meeting from rising limb, and it causes ridges, and falling limbs causes trenches. Now, this thing is becoming very difficult for me even. So what I'll do, I'll explain it, okay, and then we'll move forward, because this is creating a unnecessary thing that we'll do again afterwards. So see, there are certain plates, okay, major plates and minor plate. Consider, doesn't matter what it is, okay, major or minor. This is a oceanic plate, okay, and this is the continental plate. Now if they are moving towards each other, it is basically the convergence. If they are moving away from each other, it is divergence. Convergence, divergence. If they are moving, you know crossing each other, that we'll call it as transform boundary. Now what will happen if both of them are moving towards each other? Now if these two plates are moving towards each other, what will happen eventually? The denser one, here this is density of oceanic plate is more, and here the density is low. So what will happen? This plate will be subducted. This plate will be subducted, and the oceanic plate will take on. Okay, the oceanic plate will basically take on. So now this particular portion, that is the upper mantle, it is called as asthenosphere, and there is a convection. Now this will go down, it will get warm, okay, it will get hot after radioactivity, it will convert into magma, and then this will come again to the surface, okay, and then from here it will also pass the land, and there will be a development of mountain chain, okay, arcs, for example Andes, Rockies. Okay, so this is first thing which is important here. Now These are the two facts that we understand. अभी हमें समझना है और दो चीजों से related. This was asthenosphere and convectional circle. Next is where and what will develop if this continent, this is oceanic plate, if it is meeting the continental plate, because ऐसे तो होगा, this will not be like, there will be ocean till up to here, okay, and this height is in meters, okay, kilometers sometimes, and even land is there, okay, and what we see is basically the interaction of land. Okay, so this particular depression will be caused here. So when there will be a convergence, मतलब दोनों एक तरफ आ रहे हैं, so there will be the formation of trench. First scenario. Now in the mid-oceanic ridge, if these are the two oceanic plates which are moving like this, so what will happen? Volcano will come and then the sea floor spreading will start. So here this is called as mid-oceanic ridge. Mid-oceanic ridge. Because what happened here, a plate or two plates are diverging or going away from each other. Okay. Now seafloor spreading is a process that occurs at mid-ocean ridge. So this is the mid-oceanic ridge, which is basically, which you can find it in literally every ocean, and you can find it prominently in the Atlantic Ocean. Then seafloor spreading explains the continental drift. Now this theory of seafloor spreading, along with convectional shell theory, this thing contribute to the continental drift theory. And older rocks, as you can see that here there is a, अब यहाँ पे deposit हो गया, ठीक है. Now this thing will move forward and then there will be deposit here, okay. When this thing will move here, this thing will move to this place and it will move take this place. So the nearer it will be, if this is the mid-oceanic ridge, the younger will be here, older and oldest. All right, and at this time, that is where the trenches are forming. Okay, so when trenches is formed, this particular place, you'll find that here you will find the oldest rocks. Okay, here you will find the oldest rocks. So this is important. The next is plate tectonics theory, which was given by Mackenzie and Parker in the year 1967. Now, according to the theory of plate tectonics, the Earth's lithosphere is broken into distinct plates, which are floating on asthenosphere. So, according to this plate, so this is our Earth. Earth's crust is basically broken into these types of plates. Some are major plates, some are minor plates. Okay. And these are basically floating over Earth's crust. Okay, these are the crust which is floating. Now these are the area of interaction. So high volcano and earthquake activities. So according to the theory of plate tectonics, the Earth's lithosphere is broken into distinct plates which are floating on asthenosphere, and plates move horizontally above or below or over the asthenosphere as a rigidity. The lithosphere include the crust and top mantle, and with its thickness is around 5 to 100 kilometers in oceanic part. Okay, if we have talked about this in the earlier portion of this video, 5 to 100 kilometers, and if we talk about continents, it is around 200 kilometers. Now, this lithosphere plates, there are certain major plates, there are certain minor plates. There are oceanic plates, there are continental plates, and there are mixture of both, that is oceanic and continental. For example, our Indo-Australian plate, that is a mixture of both, that is continental as well as ocean plate. Now, there are certain things that we are going to discuss, which include the types of movement. Okay, we have talked about the three types of movement. The first is divergent, convergent, and transform movement. So we will complete that and then we'll start the new topic in new video, which is volcano, which will be volcano. Now, the how many types of boundaries are there? Three types of boundaries are there. The first one is divergent, second one is convergent, and the third one is transform. So as far as first, that is divergent is concerned, this is the two plates, okay, or one plate which is broken and they are moving away from each other. Now when they'll move away from each other, there will be creation, okay, continent, there will be creation, and finally what will happen, they'll be subducted, both of them will be subducted near the continental plate. So consider this to be oceanic plate which is broken and now moving away from each other, and hence if they're moving away from each other, they'll basically there'll be no destruction, there'll be construction. So while we are talking about the divergent, it is also called as constructive construction because construction of crust happens here. It is also called as extensional boundary, constructional, extractional, then moves away the plates which are there, which it moves away and it creates mid-oceanic ridges. It creates mid-oceanic ridges. The next here is convergent. Here the two plates, oceanic, continental, oceanic, or any three, they converge in each other. So if this is the denser one and this is the lighter one, so denser one will go down, and when it will go down, volcanism will come. Okay, and this magma will turn into volcano, and you will see an arc developing in this particular plate. So you will find the various fold mountains, okay, across the coast. You see the example of Himalaya, Andes, etc. will be an example of convergent edges. Now at the, see, if this is a continent plate and this is the oceanic plate, now we are talking about convergence, so they are going to collide. So the heavier one is ocean one. Now what will happen, the heavier one will subduct and the ocean one will remain. Okay, the ocean one will remain. So you'll realize that now this is not like, yeah, this will be like this size. So when you see that the beaches are starting here, you don't know that below that the ocean plate is basically underground. It is going. Okay. So when this magma will, this part will go in asthenosphere, convectional cell will develop due to radioactivity. A lot of heat will generate, and hence it will come out here and it will make a mountain like Himalaya and Andes that you can cite the examples. Here you will find यहाँ पे जहाँ पे समंदर होगा, you know, it will be where the interaction will take place. That is the area, right? So at that particular you will find the trenches. Trenches will be formed. And now the third and not so important is transformed boundary. So for transformed boundary, it is neither create nor destroys. As far as convergent is concerned, it destroys. यहाँ पे destroy होता है ना, this is destroying, okay. And for oceanic it is creating, यहाँ पे creation हो रहा है, so it is called as create. Construction here, destruction here, nothing takes place. And the good example for this is San Andreas. So San Andreas Fault in USA is the best example. Now, the last topic that we are going to discuss is of this particular is the types of plate. So there are three types of plate: oceanic, continent, oceanic, continent. So first is ocean. So you see that whose density will be higher if there are A and B. If one's density is higher, it will be more the density, it will be subducted. Okay, when the two plates meet and collide against each other, the denser one will be pulled under the other and is subducted, and it descend into asthenosphere. And उसके बाद क्या होगा यहाँ पे new magma will be generated and a island of volcano arc will be developed. So it will be underwater volcanic arc will be developed. For example, there is an Pacific Ocean and out of nowhere we see Fiji, Tonga, Japan, these countries, right? So these, for example, Japan, Solomon Islands, Fiji, these are Marshall Islands, okay? These are basically nothing but the example of volcanic arcs. Then there are also continent. So similar, whose density will be more will be subducted, okay? When they both will be pressing each other. So example here you can remember is Himalaya. Third is ocean and continent, which is important basically because this is a common interaction which is happening. Okay, so the oceanic plate is definitely denser. Okay, and continental plate is lighter. So what will happen? The O will go under C. This is seen. Okay, oceanic plate will go under C. The second is when it will happen. What will happen? When oceanic plate will be subducted, it will go to asthenosphere. Due to radioactivity, it will convert into magma, and now this magma will come on the crust, and then there will be a volcano. Okay, so that is how the things are going to happen. For example, Andes. Okay, second example. So this is what we talked about geomorphology. Now in the next video, we'll meet with the other topic, which is volcano. Thank you for watching. Stay tuned. Be healthy.